When talking about resistance, we usually talk about Ohm's law, V equals IR. This means that the voltage drop is equal to the current times the resistance. Ohm's law lets us figure out that this resistor, when hooked up to an 8-volt battery with a current of 2 amps, has a resistance of 4 ohms. We use the equation V equals IR in the known voltage of 8 volts, the known current of 2 amps, to find out that 8 volts over 2 amps equals 4 ohms, which is the resistance. What would happen to the current if we added a 2 ohm resistor into the circuit in series? When resistors are in series, we add their resistances, as shown in this equation. We know that the voltage drop over the circuit is 8 volts, and that this resistor is 4 ohms, and this one is 2 ohms. To solve for the current, we'll set up a V equals IR diagram. Now that we have our chart made, we just need to fill in the blanks. So let's label this resistor resistor 1 and this resistor 2. And we'll mark that over here as well. So resistor 1 has a resistance of 4 ohms, and resistor 2 has a resistance of 2 ohms. Using this equation, adding 2 and 4 together, we get a total of 6 ohms. We're given that the voltage drop over the whole current, the whole circuit, is 8 volts, so we'll plug that in here. Using the known values, we plug it into V equals IR to find out that the current is about equal to 1.3 amps. Now what would happen if instead of adding the second resistor in series, we added it in parallel? When adding resistors in parallel, you take their reciprocals and then take the reciprocal of the sum of those values. To find the current of this circuit, we need to set up another V equals IR chart. We're given the voltage drop over the entire circuit, which is 8 ohms, so we plug that in here, and we're given the resistance of each of the resistors on their own, so we plug those in here. And then we use those and plug it into this equation, like that, to find out that the resistance of the circuit is 1.3 ohms. Now that we've figured out the resistance and we were given the voltage, we can use V equals IR again to find out what the current is. So plug in 8 volts times equals the current times the resistance, 1.3 ohms. You can find out that the current is about equal to 6.2 amps. Sometimes you'll see a resistor drawn inside a dashed box alongside a battery, like this. That simply means that the battery has internal resistance. Now say that this is a 10-volt battery with an internal resistance of 1 ohm attached to a 6 ohm resistor. Now let's find out what the terminal voltage is. Say that the circuit also has a current of 1 amp. So the terminal voltage equation is the terminal voltage equals the voltage of the battery, which we'll call V sub 1, minus the voltage drop over the internal resistance. We'll call that V sub 2. Using our equation V equals IR, we can rewrite this as V sub T, the terminal voltage, equals the voltage of the battery minus the current times the internal resistance. So we're given that the voltage of the battery is 10 volts. So 10 volts minus the current, 1 amp, times the internal resistance of the battery, 1 ohm, is equal to the voltage, the terminal voltage. So that's going to be 9 volts. Objects like light bulbs and motors also contribute resistance to the circuit. Here we're given a 5-watt light bulb hooked up to a 6-volt battery. We're also given the equation P equals IV, which means that the power is equal to the current times the voltage. Given this information, let's solve for the resistance of the light bulb. So we can use P equals IV and V equals IR and combine those two equations to get P equals V squared over R. We then will plug in the power, 5 watts, and the voltage, 6 volts, to figure out the resistance. Then do some algebra and you find out that the resistance is 7.2 ohms. For this to work, we're assuming that the light bulb is perfectly ohmic, which means that the resistance is constant throughout the time that it's hooked up to the battery. This was a quick crash course to resistance in circuits.